Hello, everyone. Welcome to The Extraordinary. And if you've been following me for some time now, you'd notice that I've not been posting for the past couple of weeks. And that's because we were having some issues on our prod deployment, which I had to spend a lot of time debugging. Most of the issues have been resolved now, so I have a little bit of time to continue posting again. So I apologize for the lull in posts, but we are back on track now. So we're going to be looking at defining functions in Python, and we create functions by using the def keyword. And for as an example, let's write a Fibonacci sequence function. Let's create a new file here. Let's call it example1.py, and we create our function, say def fib of n. So let me go ahead and impute the hints on this. So by default, you want to have a text at the top of your function that basically defines what the function does. So that's what we're doing here. We'll say print a Fibonacci series less than n, and this is more or less like the doc string for this function. So let's proceed. A b equal to 0, 1, while a is less than n, we'll print a, and then we'll set the end to be a space character. Then we'll assign a and b to new values b and a plus b. Then we'll print this print just takes the output to a new line, and this is our function definition. So let's call this, for example, with fib 2000, and when we save this file and run it, what do we have? Let's see, python 3 example1.py. So we see 0, 1, 2, 0, 1, 1, 2, 3 all the way to 1597. This is how we define a simple function in Python, by using the fib keyword, by using the def keyword and specifying the name. We can also specify a parameter, and then we would write the function body in between. After writing this column, we write the function body in that function. Then after defining the function, we can now call the function. Normally a function has a return statement, but if the function does not have a return statement, we can find out the type of that function, and it is going to be a non-type. So how do we find out the type of a function? We can print the function itself. So for example, if I say print fib 0 and we run this again, we see that we get none, which is the return type of this function. So when a function doesn't have a default return type, if meaning we didn't specify explicitly, say return x, for example, it's going to return null by default. We can set default arguments when defining the parameters of a function, and let's take a look at how that would look like. So for example, let's say example 2 dot by. If we define this, df asks okay, prompt retries equal to 4, reminder equals please try again, and inside the function we say while true reply equal impute prompt. Then if reply is in y, e, or yes, then we return true. Okay. If reply in y, e, or yes, let me see. There's something I'm missing here. Okay, I didn't define it properly. Reply. Now if reply in n no nope or loop, then we return false, and then retries equal to retries minus 1, and we say if retries is less than 0, raise value error, invalid user response, and print reminder. So let's go over this function that we just defined. While true, we're going to assign a value that we get from the user's input to a variable called reply, and if that value is y, ye, or yes, then we return true. If the value is n, no, nop, or nope, then we return false. If none of these matches, then we reduce the number of retries by 1, and then we basically go over this loop again. We do this all again and again until the number of retries becomes less than 0. At that point, we raise an invalid user response. Each time we are going to be printing this reminder of please try again, please try again. Let's see an example of this. So for example, if we do ask okay, do you really want to quit? Notice that we passed in only one value, only one argument. The reason why this would work is because retries has a default argument of 4, and the reminder has a default argument of please try again. So let's see how that would work. So let's say Python G example 2. So you see, do you really want to quit? If we put in, let's try putting in something that does not exist. Let's say, what do you mean? So it tells us to please try again. And if I say no, it says please try again. If I say no again, it goes off. So the first time it tells me please try again because I put in a space in between no and the input. But when I put in no, it just went out of the loop. So if we should try this example again, do you want to quit? If I say yes, this time it breaks out of the loop, but I'm not getting return true. Oh yes, the return statement that I'm getting is not being printed to the screen because I'm not printing it. So let's say, for example, we do print. Let's print this instead. Let's see, print this. Right. So now this should be printed to the screen. Let's see. And I say yes. Yeah. True will be printed to the screen. If I try it again and I say no, false is printed to the screen. This is good. Now we could also decide to use, instead of 4 retries, we could say we want to do 2 retries. So let's duplicate this, comment this one out, and change 4 to 2. Now if I try this again, if I put in something that does not exist, I say who, it says please try again. And if I say what, please try again for the second time, and if I still give it a value that is not existent, why is it giving me this? Number of retries is supposed, oh sorry, I put the argument in the wrong place, so it's supposed to be here. Save. Now let's quit this. Let's try again. So I say who, let's try again, and I say what, let's try again, and I say why. So that's 2 times that's giving me please try again, and it goes off. So what does it say? Line 14. Okay, so there is this raise error value, but we can't print that, so that's why we are getting all this error. So as you can see, value error, invalid user response. So basically what this shows us is that we can give our functions default values. If we want to specify default values, we can specify default values while we are defining the function, and those values can be modified when users are calling those functions. In Python, when defining functions, there is something called keyword arguments. So basically, we could, instead of passing in the values, we can specify the keyword that represents the exact argument that we are trying to pass in. So for example, let's create a new file. Save this as example 3.py. Okay, so we define this function called parrots, and as voltage as a parameter, state which is equal to a staff, action, default value is voom, type equal to Norwegian blue okay. We'll say print this parrot wouldn't action and equal to this. Then next line, just duplicate this. So the next line is if you put voltage comma volts through it, then the next line is lovely plumage, the type, and then finally we have its state, comma, and exclamation. We can call this with just parrot 1000. This is what is known as a positional argument. Why? Because we are just based on the position of the argument, it would set the corresponding parameter. So 1000 will be set to voltage. So if we call it like this, we set this and we print and we run this example 3. So we see this parrot wouldn't zoom if you put 1000 volts through it. This is supposed to be through. Let me correct that. So this parrot wouldn't zoom if you put 1000 volts through it. Hold on, let me run this again. Through it. Very good. So this parrot wouldn't zoom if you put 1000 volts through it. Lovely plumage, the Norwegian blue, it's a staff, right? So the only thing that we modified here was the voltage value. Now we could also modify this by specifying the keyword of the parameter that we want to change. So we can say voltage equal to 1000, and that has the same effect. Let's change it to 100 in this case. It has the same effect as before. So if I change this and run it, now we see that it's 100 volts instead of 1000. This is the keyword of the parameter that we are trying to set. We could also set multiple parameters with the keyword. So we can say voltage is equal to a very high number, and then action is equal to zoom. Okay, now what we're doing here is still using the same keyword pattern of setting parameters, and when we run this, we see that the value changes for both the action and the voltage. We could also do a combination of positional setting and keyword. So for example, we can say parrot a million, and then state pushing up the daisies. If we run this now, what do we have? So this parrot wouldn't zoom if you put a million volts through it. So you see now it's using a million as the volt parameter, and then the state is lovely plumage in Widambu. It's pushing up the daisies instead of the original state of a staff. It's pushing up the daisies. This is how we pass in arguments in different forms in Python. So again, we can do positional. We can use the positional value. So what we put in first is used for the first parameter. What we put in second is used for the second parameter. Or we can use keywords where we indicate the name of the parameter that we want to pass in, or the name of the parameter whose value we want to pass in, and then we pass in that value for that parameter, and so on and so forth. And we could also use positional and keyword. So we put in the correct parameter for a particular position, and then we indicate the keyword in subsequent instances. So these are the ways that we can pass in parameters to a function in Python. One thing we should note is, if you notice, I've been using the words parameters and arguments interchangeably so far, but they are not exactly the same thing. The parameter is part of the function signature. So what we have here, voltage, is a parameter, state is a parameter, while an argument is the value that is passed into that function. So for example, in this case, a million is an argument. Pushing up the daisies is an argument. So that's the difference between a parameter and an argument. We can specify how the parameters can be passed in to our functions. We can indicate whether we want the parameters to be positional only, positional or keyword, and keyword only. So how we do this is we use the / and asterisk as needed. So for example, let's create a new file, example 4.py. Right. So we'll define 3 functions in this file. The first function is standard arg, and here we are just passing in the function as we are just passing in the parameter as normal, and we print that value, the parameter that was passed in. Then for the next one, we are doing pos only arg. So we're saying that only positional values or arguments can be passed in. So we'll put in arg, /. So this / is what tells Python that the argument here can only be passed in as a positional argument. Then we go ahead and print it. Next, we define keyword only arguments, and here we use the asterisk to indicate that these arguments can only be passed in via keywords. We print in the arguments here, print out the arguments here. Then finally we do combination, so combined example. So we have pos only, then put our /, put standard, and the standard is both positional and keyword argument, and then we put asterisk, and finally we say keyword only. Now we print pause only, standard, and keyword only. Okay, so let's see an example. So if we call standard with and passing an argument 2, we get what we pass in. So let's try and run that. Let's say example 4, we get 2. That works. Now let's try to call it as a keyword. Remember, we indicated that it is standard, so both keyword and positional are going to work in this case. So we say arg is equal to 2, and we run that, and of course it works. But if we do the same thing this time around, calling the pause only function, so we say pause only, and we do the same thing when we pass in the argument as a positional argument, it works fine, we get 1. But if we try to pass it in as a keyword argument, let's say arg, what do we get? An error. Why? Because we've already indicated that this argument can only be passed in as a positional argument. So that's what happens when we do that. So if we are trying to enforce some sort of rules around how the arguments are being passed into our functions, this is a very handy way of going about it. So let's do for keyword only. So for keyword only, it's the opposite. If we try to pass in for keyword only, we try to pass in as a positional argument, it throws an error. But if we try to pass it in as a keyword argument, we get the correct value. Right. So these are the ways that we can pass in. We can define how arguments can be passed into our functions. We can enforce them to be passed in as position only arguments, as position and keyword arguments, and as keyword arguments only. Let's just do the last example for the sake of it. So for example, if we have combined example 1, 2, 3, we save that. Let's clear. Right, we get an error. Right, because it expects 2 positional arguments, but 3 were given. Why? Because 1 is the positional only, and then the other one would come from the standard, which accepts both positional and keyword arguments. And then finally we expect a keyword argument. So let's try an example that would work. So we do combined, we say 1, 2, and then keyword only is 3, and now this works fine. Right, so nice. We could also specify this as combined example. We could say 1 standard is 2, and then keyword only is 3. This works as well. Why? Because standard accepts both positional arguments and keyword arguments. So this would work as well. That's very nice. Now we could have an arbitrary argument list. So think of a situation where you don't know the number of arguments that you are going to have, right? So that's where this arbitrary argument list comes in handy. So for example, we could say, let's create a new file. We could say def concat, and then we have our argument here, args, arguments here, and hold on, I didn't save this file. So let me save it as example 5.py. Okay, so we have our arbitrary argument list, and then we can come in here and do return, let's say /join args. Okay, and then we can print it here by saying print concat at Mars Venus. Now if we run this example, we are going to get a concatenated string, which is just a string that has been joined together, but it's going to be delimited, or it's going to be separated by /. So let's see that. So we see Earth, Mars, and Venus. We can pass in as many parameters as we want, or as many arguments as we want to this concat function, because we have defined that it's going to be an arbitrary list of arguments, so it's going to accept that. You can say, for example, separator. We can't do that. Why? Because after this arbitrary argument list, we can only add in a default value. So we can do separator equal to /. Now if we want, we can change this to a dot, and when we run it, hold on, yes, so we have to put in the keyword. Can say separator equal to dot. So now okay, we have to use the separator here. Separator, right. So if we save and run, now it has changed to Earth.Mars.Venus. If we are trying to call a function and the arguments for that function are already in a list, we can unpack that into the function. So let's look at how that would look. Let's create a new file, say example 6.py, and here we define, we can say list, or let's just print list of range 3,6. Remember what we said about our range? It behaves like a list, so it gives us the values that looks like a list that can be passed into the list function, which is now printed by the print function. So let's run this and see how it looks. Okay, that wasn't printed. Why wasn't it printed? I think we didn't need to add print. Let me see. Okay, let's see. It wasn't printed as well. What's happening here? So print. Okay, let's define a variable. Let's say items is equal to this, and then we print items. Okay, right, so this gives us what we're looking for. I wonder why that didn't work before, but it's fine. So it gives us what we are looking for. We can unpack these arguments and pass them into the list function directly. So for example, we can say args is equal to 3,6. So we see that 3 and 6 are in an array, or they are in a list. Now we want to unpack this list into the range function that we need. So we'll say items equal to range 3,6, asterisk args. Now we can print, we have to list first, list the range, and now if we print the items, we get exactly the same result. So this asterisk operator here is basically unpacking this 3 and 6 from the args list and passing them into the range function as individual arguments. That's what this is doing. So we can have a list and then just pass them into the function as they are needed. So we could do the same thing for collections using the double asterisk. Let's create a new example. Say example 7.py. Right, now if we do our parrot example again, let's go back to it and just copy the definition. We'll come back to example 7 and paste. Right, it saves us a lot of typing. Now instead of passing in the parameter, the arguments one after the other, we can have a dictionary or collection which defines each value, each argument. So we have voltage 4 million, we'll have state bleeding, demised, and then we have the action to be Voom. Okay, now if we do parrot asterisk d, these values here, they are going to be unpacked into the function as keyword arguments. Let's see how that goes. So let's run this 7.py. Hold on, what's going on? Example 7.py. Let me close the others. Open the side. Example -7. There is no file called example -7, but I'm looking over. it used comma instead of dot. Alright, so this is it. Can we see? This parrot wouldn't zoom if you put 4 million votes through it. Fantastic. So that's how you unpack argument lists into a function, either as a list or as a collection or dictionary. In Python, we have what we call lambda expressions. It's a signature for you to be able to write a function without a name. So how we do this is, let's create a new file, save it as example8.py. So we define a function called make incremental. Now inside this function we can use a lambda expression, then n, and this is basically another function. The only difference here is that now we don't need to do def, we don't have this parenthesis around it, around the variable. This is just the signature for defining the function, and it also has access to the parameters that are outside, that are within the same scope as it is, so n can be accessed from here. So let's run this and see how it looks. We'll say f is equal to make incremental 42, and if we run f0, what do we get? I'm sure we have to print this. Let's try it out first. 8. Yeah, we have to print it. Print f of 0, 42. And what do we get if we do f of 1? F of 1. Sorry, let's print f of 1. 43. So basically it's incrementing through the numbers that we are using. We also have what we call documentation strings. When you are writing a function, you can specify a string that can be used to document the function. So we have something like, let's save this. Now here we define my function, and then we can say, we can define, write the documentation string, say do nothing but document it. And here we can have multiple lines. After the first line we give a space, then from the next line, which is the third line, we can now start documenting the function properly. So no, really it doesn't do anything. Right, so just pass this. Now if we want to print this, we do print my function dot doc. Right, so now when we run example 9, we get to see the documentation. Nice, right? So that's it for functions. There are some other things here, but I'm not really going to bore you with it. You can go over it if you want. For the next episode, we're going to be looking at data structures, starting from lists and how we can use them in our code. If you've liked this video, please like, subscribe, share with your friends, and I'll see you in the next one. Bye.